Decentralized finance, or DeFi, is one of the most popular ideas among blockchain developers, but unfortunately, there isn't much information on the standards available. So, we bring you a talk on a standard for tokenized vaults that will lower the integration effort. Welcome to another episode of PEEPanEIP, an educational video series where we talk about different proposals, upcoming upgrades, and the basics of Ethereum blockchain. I'm Pooja Ranjan, and today we are going to discuss EIP-4626 tokenized vault standard with one of the co-authors. EIP-4626 is a standard track EIP of ERC category proposed in December 2021. This is merged as a standard to Ethereum repository in March 2022. To have an overview of the proposal, we are joined by a very special guest and co-author of this proposal, Jadeja. Jadeja is a Solidity dev at Rari Capital, a DeFi project that offers lending, borrowing, and earning yield on every asset. Thank you for joining us, Jed.
Thank you for having me.
I'm looking forward to learning more about the proposal, but before we get there, may I request you to share on your background and the journey with Ethereum for our viewers?
Yes, sure. So my name is Jadeja. I'm a 16-year-old Solidity developer at Rari, as Pooja just said. I've been working in the Ethereum space for about a year and a half now, around 2 years. I originally started working on blockchain technology with Transmissions 11 back in around 2018. School had just gone online and we wanted to make some cool projects, so we decided to build a blockchain. And that's really how it all started. So we ended up joining Rari Capital, and we started, working on some incredible projects. One of those projects were these things called vaults, which are, allow you to earn interest on a variety of different assets. And what we realized is that integrating different projects into these vaults was really difficult. You'd have to write a new integration, which took time. You also had to get it audited, which took a lot more time and was also very expensive. So what we wanted to do is create a standard that we wanted to standardize the process of yield-bearing tokens and vaults. And we partnered up with multiple different people around the space to do that. And we created 4626.
This is incredibly interesting. You are a very young developer, definitely the youngest one so far we have in this show. So welcome to the show, and thank you for joining us. So this is about the proposal 4626. So without further ado, let's peep in.
Awesome. So let me share my screen really quickly. We can just go through the proposal, and then I also want to show a code example to show you just the basics of writing an ERC 4626 implementation, and then also showing you how simple it is to integrate 4626 into your project. So this is the 4626 specification. The co-authors are Joey Santoro, Transmissions 11, me, Alberto from Yield, and Senor Dago, who's a Vyper contributor. So we created 4626, as I just stated, because the process of writing integrations for yield-bearing assets was really complicated and really expensive, time-wise and money-wise. So basically what 4626 is a yield-bearing token, which is essentially an ERC20 token that has an underlying asset that you can deposit into, and it's supposedly supposed to earn interest on that asset. So the 4626 standards implements the ERC20 standard so that the balance representations are completely fungible. So you're able to transfer yield-bearing token balances around. So just going through some of the definitions, the asset is the underlying token managed by the vault. It's supposed to be an ERC20 contract. The share is the token of the vault, so the vault ERC20 asset. It has a ratio of underlying assets, which is exchanged on mint, deposit, withdraw, and redeem. And the yield-bearing assets are supposed to, the yield-bearing shares are supposed to increase in value. So the ratio from underlying to shares should increase over time. The fee is basically an amount of assets or shares charged by the user, by the vault, Fees can basically exist for deposits, yield, AUM, withdrawals, or anything else prescribed by the vault. And then slippage is basically any difference between advertised share price and economic realities of deposit to or withdraw from the vault, which is not accounted by fees. So we have a bunch of different methods written through in this specification. We can go through the view functions first. So the first one is the asset, as we just talked about. It returns the address of an ERC20 token that is accepted by the vault. The next one is total assets, which is the total amount of underlying assets that is managed by the vault. It doesn't take in any parameters, but it returns a unsigned integer. The next function we have is convert to shares. And it basically gives us the amount of shares that the vault would exchange for the amount of asset provided. So say you want to, say you have a protocol that wants to deposit into a vault, and that protocol wants to know how many shares they will receive after that deposit. They can simply use the convert to share function to see how their yield bearing balance is going to increase.
You might want to use, I mean, there's a lot of just all of the terminology going around, and of course you use this. You're probably developing this with Rari. Do you think it might be easier if you like gave an example of a fuse pool or something like that that was using 46 in terms of like what's getting deposited, what you're holding, and kind of what you expect to see in a case like this?
Yeah, for sure. Yeah, so I'll use the Rari vaults as an example. With Rari vaults, you're going to be able to create a vault for basically any asset that's supported by Fuse. And it's essentially a yield aggregator, so it will deposit into the Fuse pools that have the highest interest. So for a quick example, let's use like a USDC vault. So for the USDC vault, you have the underlying asset set to the address of USDC. And then you'll have RVUSDC, which is the share token. So initially, the ratio between the asset USDC and the share RVUSDC is going to be 1-to-1. However, as the vault earns more and more interest through using Fuse, the value of the share is going to go up. Do you think that's a sufficient
Yeah, sure.
example? Okay,
so basically what you're saying is that with the amount of the RV token that I'm holding, I would expect the, what was the name of the function again? The convert to shares. I would expect the result of convert to shares to go up on a static amount of the RV token.
Exactly. I mean, technically the value would start going down because the ratio between underlying and shares is going to decrease. However, the value of the share is going to increase. So the convert to shares is going to decrease, but we have another function called convert to assets, which allows you to put in an amount of shares and get out an amount of underlying. And then that value is going to increase as the value of the shares increases as well. And basically as the vault accumulates more and more underlying. So as like say, going back to the USDC example, as the USDC vault earns more and more USDC through depositing into the Fuse pools, the convert to shares, so the amount of RVUSDC you can get from putting in USDC is going to decrease. However, the amount of USDC that you're going to get from RVUSDC is going to increase. So convert to shares is usually going to be used for deposits so that you can calculate exactly how many shares you're going to be getting when you deposit, and convert to assets is primarily going to be used for withdrawals so that you can see how many underlying tokens you're going to get when you execute a withdrawal. The next function is the max deposit, and that tells you the maximum amount of underlying asset that can be deposited into the vault for the receiver through a deposit call. So yeah, I mean, this essentially, it's pretty simple. It just returns the amount of underlying assets that can be deposited. And if there's no limit, it just returns the maximum integer size, which is 2 to the power of 256 minus 1. The next one is preview deposit, which is very similar to our convert to shares function. However, this is essentially a simulation. So you're able to, you're basically able to simulate so in most cases, for most vaults, preview deposit and our other function convert to shares are going to have the same output. However, there's some cases where there's, say, like slippage, where they might have different outputs. Then finally, we get to deposit, which is the actual interaction where you mint shares to the user who's depositing to the receiver by depositing exactly the amount of underlying tokens. So we take in the number of tokens, so the assets, and then we also take in the address of the receiver, so the address who's receiving those shares. And then in return, we get the number of shares. And this is actually, so there's a lot of vaults and protocols that don't return the number of shares being minted. So it requires you to make a call before depositing to check your balance, and then make a call after depositing to check your balance after the deposit. And then you're able to just subtract the newer one from the original one to get the amount of shares minted. However, that's a really inefficient way of doing things. It requires 2 extra calls. Whereas here, we're simply making a bit of extra return data to return the amount of shares minted, which is definitely going to help a lot of integrators. We really wanted to prime ERC-4626 to focus on integrators, because I mean, the whole reason we created this this ERC is because of the difficulty to integrate within different protocols. So a lot of these functions and a lot of these methods are going to be focusing on trying to make the experience for integrators better than it currently is. By the way, do you guys think that going through each function is the best way to go through things, or would you prefer that we go into the code? How do you guys think we should go about this?
I think a function overview is probably a good idea.
Cool.
I mean, the thing with code is that people could use it. They could also implement something else. There's a Vyper 4626 running around. Like, you know, who knows if someone's going to want to need it? You know, they're pure tweetable bytecode 4626. So like, no, there I think is probably really the best way to start.
All right, perfect. So yeah, just going through the next function, max mint. It basically allows you to put in the name of the receiver, and it gives you the maximum amount of shares that can be minted from the vault to the receiver. And what's useful about this is it enables developers to, say, have like a, for example, like boost shares to a specific user. There's a lot of use cases enabled by this, rather than just having a maximum deposit value. The next one is a preview mint. So going through the actual interactions, we have multiple ways we have 2 ways to deposit and 2 ways to withdraw. We have a deposit function, which takes in the amount of underlying tokens you're depositing and returns the amount of shares that are being minted. You have a mint function, which takes in the amount of shares that you're minting and returns the amount of underlying tokens that you want to deposit. And there's also 2 ways of withdrawing. So you have the withdraw, which takes in the underlying amount of assets and returns the amount of shares that are being burned. And then you also have redeem, which takes in an amount of shares and returns the amount of assets that you are being returned. So this is basically the same as preview deposit, except it takes in the number of shares rather than the number of underlying tokens. And then, yeah, the mint function. So it mints exactly the exact amount of shares to the receiver by depositing the amount. So it takes in shares and then returns the amount of assets. Max withdraw is it basically enables the user to see how much, to see how much, the owner to see how much they can withdraw. This is really useful for a lot of different protocols. I'll use vaults as an example. We integrate into Fuse, which uses Compound. And the thing about Compound is that sometimes when there's a lot of utilization, you can't withdraw all of your funds from the pool. So by having a function that tells integrators how much or the maximum amount that they can withdraw, you'll be able to prevent like reverts, for example, because they're able to see ahead of time before withdraw if the vault doesn't have a certain amount of funds for them to fully withdraw.
I don't know Compound off the top of my head, but I'm wondering, is that even more insidious for, like, if Compound puts a max cap on a withdraw and you feed them a figure that's bigger, does it outright revert on you, or does it give you as much as it can, or does it do something even weirder?
Yeah,
like, don't pop quiz you on that. Like,
all good.
Spot.
Oh, good. No. So I'm pretty familiar with the Compound code base. So yeah, it's gonna revert. Compound will basically check how much they have on hand. And if too much is being borrowed, it'll basically just revert. But you're able to check in the math. You're able to check how much Compound does have on hand. So in the max withdraw function, you can just return that value.
Yeah, I'd imagine that there probably are platforms that do even weirder things in a case like that, which would also make a function like this, like, just so useful in terms of not getting weird side effect external call behavior.
Yep, 100%. Moving on to preview withdraw, basically does the exact same thing as preview deposit and preview mint, except for withdrawals. You put in a number of assets and it will return a number of shares that are being burned. This is the actual withdraw function. It takes in 3 different parameters. First, it takes in the number of assets that you're trying to withdraw. It takes in the receiver, so the address that's receiving those assets, and then it takes in the owner address, so the address whose shares are being burned. So that enables things like you can call an ERC-4626 vault to withdraw somebody else's shares as long as they approve of that. And when we go through the 4626 implementation really quickly later in the show, I can show you exactly how that works. But this can be really useful in a lot of different cases. Going to max redeem. Like I said, the redeem function is similar to withdraw, except it takes a number of shares in rather than a number of underlying assets. Yeah, so that one's pretty simple. Then there's preview redeem, which does the exact same thing as preview withdraw, but takes in a number of shares. Now is the actual redeem. So yeah, it burns the exact amount of shares from the owner and then sends those assets to the receiver. So going through the events, we wanted to add quite a few events to make it easier for integrators, because as I said earlier, we want to try and really make the experience for integrators as beneficial as possible and as easy and smooth as possible. So the deposit event takes the name of the caller. And the reason why is because our deposit functions, as we went through earlier, take in a recipient address. So even though I could call the deposit, the shares could be sent to another address. The withdraw function. Oh, sorry. Let me go through the rest of the deposit event. Okay, so it takes in the caller, the owner, the amount of underlying assets being deposited, and the number of shares being minted. Withdraw is very similar. It has one more variable, one more parameter. So it takes in the caller, the receiver, which is the address that is receiving the underlying tokens, the owner, the address who owns the shares, and then as well as the underlying assets being withdrawn, and the shares being burned. And yeah, I mean, that's about it. So there is a Vyper 4626 and solmate 4626 implementation. And then Open Zeppelin is actually coming out with a 4626 implementation really soon. So yeah, I mean, I'm much more familiar with the solmate 4626 contract. And basically it's implemented almost all of this logic in a really efficient manner. However, there is some functions that you're going to need to implement yourself. One of them being the total assets function. And that
basically— I just want to kick up the screen size.
Yes, my bad. Is this better?
No problem. Yeah, that's not more readable. Yeah, that's great.
Great. So yeah, the total assets function, and that basically tells the contract how many underlying tokens the vault has. And the reason why the user has to implement that themselves is because the vault, you're going to have to call, you know, other contracts to see how many tokens you have. For example, with vaults, we take in the amount of underlying assets owned by the vault or that are held by the vault, as well as our balances and all of the fuse pools that we've deposited into. The next few functions that you need to implement is just the before withdrawal. And all that does is, all you need to do is implement the withdrawal from other protocols. So for vaults, for example, the before withdrawal function basically just withdraws assets from the fuse pools that were deposited in. And then the after deposit function, which deposits assets into whatever protocol that you're integrating into. So if we want to look at a mock implementation, it's literally less than 30 lines of code. All you need to do is inherit from the 4626 contract and then implement total assets, then a before withdraw and an after deposit. And that's really all there is to it. I mean, you can add as much extra functionality as you want to, but the base 4626 contract is just all of this. And then it has all of that logic for depositing, like preview, deposit, all of that stuff is in this contract. But all the developer has to do is just implement these few functions.
Well, I mean, and also like vault logic so that it's actually doing something.
Yeah, yeah, of course. But yeah. Yeah, it's a lot better than having to write all of that stuff yourself for sure.
Yeah, absolutely. I mean, for anyone who's familiar with it, it makes it a lot closer to, say, developing the ERC20 token. Like a lot of most of the times, you're just pulling in a template like Solmate or OZ, and then doing your funky stuff on top of that.
Yep.
Well, thank you so much. First of all, congratulations for this proposal being merged to the Ethereum repository.
Thank you.
I mean, EIP-4626 made it in a very short period of time. Now I understand why, because of so many people working together, I suppose. And yeah, I'm sure this will help new projects looking for some standard API for tokenized vaults. I have a few questions. If anyone else has any technical question, please write it on the chat. I think William Schwab, you may have some question. You want to go ahead first?
I see some from Vex who said they don't have a microphone, so maybe I'll just read this out first. So 2 questions. In Fuse V2, will all fTokens adhere to the 4626 standard? If so, how has the conversion process gone so far?
Okay, so bit of alpha. So every Fuse pool in Fuse V2 is going to be within a single contract. And with 4626, you can only have a single underlying asset. So with the current Fuse protocol, which uses Compound, you have a comptroller contract, which is the center, and it connects all of these other contracts called fTokens, which are basically their own yield-bearing assets together. With Fuse V2, in order to have a much more efficient architecture, we opted to have every single Fuse pool as a single contract. And as a result of that, before in every single deposit, you have to specify which asset you're depositing. And same with pretty much every other function, which makes it impossible to use 4626. So no, however, there's a lot that Fuse V2 there's a lot of 4626 related things that Fuse V2 is going to be using. For example, plugins. When you deposit your assets into Fuse V2, they're automatically going to be held in a 4626 vault. And that will basically enable you to earn interest on idle funds, which is it's something that we've integrated into Fuse V1. However, in Fuse V2, that's going to be enabled by default, and it's going to be built off of 4626.
Just because I can't help asking, when you say that all the Fuse pools are going to be contained in one contract, are you going with a Helios-like structure? Like everything's going to be in 1155?
Oh, sorry. Exactly, except we're not going to have we're not going to have a fungible balance representation. So we're not going to be using, 1155. However, you can easily create a 4626 vault contract that wraps around the fuse pool.
Mm-hmm. All right, and Vex's second question, is there a need and or a want for a 4626/2612 implementation of the standard solmate? Would be to work on it?
Sorry, do you mind repeating that? You cut out a bit.
Oh, sure. Let me just check that. Basically, Vex is asking if there's any work being done to integrate 2612 permits into 4626 in solmate.
Not at the moment, but that's something that we can definitely start working on. Yeah, I'm not too ahead of solmate right now. I've stopped really following along other than the 4626. But at the moment, as far as I know, there's nothing being done connecting those two.
Mm-hmm. So then maybe actually something from me. So it looks like 4626 spends a lot of time trying to kind of simulate so that you know what you're going to get. You can simulate things coming in, you can simulate slippage. How does that, how do you, what's like the expected usage there? Because if you're fully simulating before you actually do the transaction, so then an ME searcher or someone of that general sort could already change kind of your scenario in between when you simulate and when you submit. Do you expect it to actually be wrapped into transactions and then revert under certain conditions?
Yeah, so the simulations are all like view functions. So you're not going to be able to see those on chain. And the other thing is, I think that people who are, depositing through an EOA are not going to be using the preview functions. It's mainly going to be used by contracts and potentially by interfaces. But I think that the main use case is just to ensure that you're not depositing when, some sort of unexpected behavior is going to occur. And, we originally weren't going to add this, but Senor Doggo brought up, quite a few reasons why it's important. There's a lot of times and there's a lot of protocols where there's, things like slippage and the integration or the integrator protocol doesn't really expect that. So by having preview functions, they're able to see ahead of time exactly how much they're going to be getting out.
Very interesting. Yeah, I can see for contracts, especially where that would be really, really necessary. Doggo was head of security at Yearn for a while. I guess I'm unsurprised that he had a good grasp on all the. Very cool.
Thank you. So now the technical part is there. I have a few process related questions. The first one is related to implementation. The proposal refers to implementation in Solidity and Vyper, and Rari Capital has implementation. You did mention that there is an implementation in OpenZaplin coming up. I was wondering, if you are by any chance aware of any other project they are planning to implement. There is demo of Vyper. Do you by any chance know the name of the project?
Sorry, the project of the Vyper implementation, or
that's right.
I believe that's in one of Senor Doggo's repositories. We just took a look at that right now. So at the moment, I think that other than that repository, the solmate contracts and OpenZeppelin, those are really the only projects writing their own implementation. But then there's going to be a lot of projects like implementing that or integrating it within their protocol.
I do believe so. This is quite an interesting proposal. So we are expecting more projects to be implementing that.
And I did see that Yearn did plan on working with 4626, which makes it a bit suspect that Doggo was putting out a Vyper, Vyper 4626, because Yearn's vaults are all in Vyper. Exactly, so I would say it's at least suspect that that implementation is there for Yearn.
Yep.
Interesting. Well, my next question is related to motivation. This proposal received over 75 comments in the discussion tool thread since January, and in less than 3 months, the proposal is merged as final, and they have received a lot of conversation. Would you like to share at what point authors of the proposal decided to push this as an ERC instead of just going ahead simply with the project development, coding it, and just development? What would be the basic motivation behind documenting it as an Ethereum standard?
I mean, we thought that going with an Ethereum standard would get the most, as much adoption. And we wanted to get as much adoption as possible. And we felt like going with an Ethereum standard would be the perfect way of getting there. And really the reason why we created this is because being an integrator and working with yield aggregators and other protocols was very difficult. It's very difficult to write integrations for a lot of different projects, especially when you have to get all of them audited, which takes a lot of time. And it's also quite dangerous. In July, I believe, of last year, Rari Capital got hacked, our ETH pool, due to an integration with Alpha Homora. And what was very interesting is we had gotten that integration audited, we had sent it to their team, and they had approved of it, yet it still got hacked, which shows how having custom integrations can be quite dangerous, especially because auditors don't look into the code base of other projects, right? They're only really hired to look into your own code base. And then we also got it reviewed by them, and they didn't raise any problems. And that definitely shows the dangers of having to write integrations, whereas with a single standard, it's a lot harder to have problems like that. For example, with ERC20, if I want to get, say, USDC, like a USDC integration, I don't have to go to the USDC developers and get my integration audited by them. I can simply integrate it and have independent auditors do that. With 4626, we wanted to speed up the development process and also make the contracts safer. So one example that I like to bring up a lot is Uniswap. Say there was no ERC20 standard. Imagine if every time you wanted to create a new Uniswap pool, the Uniswap developers would have to go through, write a whole new Uniswap pair contract based on these new tokens, and then get that audited. The space would be behind by so much because you wouldn't be able, because being able to create these Uniswap pairs would take months and months. And that's currently the state of yield-bearing tokens and integrations. So I think that 4626 is really going to speed up that process. And we're going to see quite a lot of innovation similar to the innovation that happens around ERC20.
That is quite inspirational here. I know the DeFi project, they are generally relying on the audits, and when even after audit something goes wrong, people try to come up with a standard. That is really incredible of you guys of documenting is as a standard for many other developers who would be coming in future trying to have something implemented in there. My next question is related to EIP process and directly. As I have been repeating it constantly, like this is one of the fastest moving proposal. According to a stat from 2021, only 20% ERC proposals made it to final. This may be an old number, but ratio of proposed versus final EIP is generally low. There could be many reasons for that. Some people think that the process may be one of those. I'm curious to understand, as an author, what was your experience documenting, maybe implementing or championing this proposal to bring it to the final status?
I mean, it was like a lot of fun. We really got like all of these smart people into like one Discord group chat, and every day we contribute to the standard. We had a lot of like calls, a lot of discussions, a lot of like even arguments and debates. I think that the experience is good, and I didn't realize how low the finalization rate was. Like that is crazy, 5 to 1 or 4 to 1, sorry. But yeah, I think that it was a really great experience. I wasn't the one making the like PRs, but based on what some of the other co-authors did, it was pretty smooth. Yeah,
that's good to hear. And I would sincerely hope that if there is anything that you guys find that could help the present standardization process, feel free to share it with us, with Ethereum Cat Herders.
Definitely, yeah. I can't put in too much input. Like I said, I wasn't the one making the PRs, but you know, as far as I know, it was a very smooth experience.
All it takes a coalition of some of the best platforms in DeFi all working together, and you can get through the EIP process pretty fast.
Yeah, exactly. Yeah.
Yeah, that's one of the key. I think implementation definitely helps. Like if people are adopting that proposal, if projects are implementing it, that definitely help push it faster.
Yeah. The other thing is from the day we started working on 4626, we started like advertising it, and we started reaching out to people. There was a lot of like tweets about it as well. Yeah, all of these projects put it in their like roadmaps and everything. So I think that we got a lot of attention, and that was something that really helped. Whereas there's a lot of ERCs and a lot of EIPs that, you know, don't have that much attention, and, you know, are less likely to get passed. So I think the key is really getting a lot of people to notice, and you know, through that you're more likely to get approved.
I mean, this might be a bit of a tangent, I hope not, but I think there's also maybe a circular process even. I mean, when you look at something like standards, so something like 4626 is actually why we have standards. If you think across all of the different people whose life gets made easier, if you have an expected interface from something like a vault. Right now, when you're building something like Zapper or Zerion or on-chain like Instadapp or DeFi Saver, they literally have to build a module for each platform out there. Whereas if we expect a certain interface, so much work for so many people becomes instantly easier. And I think it's something that differentiates things like 2721 and 1155 from a lot of other ERCs, or something even more generic like 165, which is that they're very general concepts that can get used in a ton of different places. And that's really what standards excel at. I think one of the reasons why there's a lot of ERCs that might not make it the distance is specific because they're very niche and very specific, even if those specific niche ideas have merit.
Yeah, and I mean, you can kind of see how general we made 4626 through some of those functions, like the preview functions, like the max functions, all of that. We wanted to add those because, you know, there's so many things that you could do with tokenized vaults and yield-bearing assets. We wanted to try and have 4626 cover a wide variety of different places and different projects. And yeah, I think optimizing for that was definitely something that really helped get us finalized.
Thank you for sharing. I hope these tips help new authors push their proposals towards final. All right, my last question is related to security consideration. The proposal carefully documents many security considerations for using this standard. Of course, it requires careful implementation in different projects. People may have different projects and implementation may vary. I'd be curious to hear from you if there is any specific security consideration that a project developer shouldn't miss under any circumstances. Would you like to talk a bit about so project dev be careful while implementing EIP-4626 in his or her project?
Yeah, so so for people who are implementing it within their project, I think that like 99% of protocols and projects that are using 4626 are going to use either the OpenZeppelin, Solmate, or Vyper implementation, which really covers the majority of the logic that you need to implement. However, there's for projects that are not using those, which may have, you know, some more modifications that they might want to make. It's definitely a bit more dangerous to do that and implement that logic by yourself. So yeah, I mean, in terms of actual like you know, anything to look out for as an implementer, I'm not entirely sure. I think that, you know, there's a lot that can go wrong. So sticking to the 4626 implementations that have already been written and are widely used is probably the best way to go. Now for integrators, I think that you want to try and use some of those view functions like the max deposits, the preview functions, and the exchange functions, because those were put in place to help avoid any like unexpected behavior. So I think that if there are any protocols that you are using that have things like exchange rates that can drop or like bad debts, such as the lending market like Compound or Fuse or Aave, to really use those functions, because they're there for a reason and they're there to make the life of integrators a lot easier.
Thank you. Thank you for sharing all these valuable information. Well, anyway, we are close to the wrap-up time. Anything else, Jed, you would like to share with our viewers related to this proposal or in general?
Yeah, so one last thing. I think that if you're, not feeling like fully comfortable, if you're unsure about implementing 4626 within your project, I think it's really important and really essential that you do so, because 4626 will definitely enable a lot of other projects to be able to use and integrate within your integrate your project into their own code bases, and it makes the lives of developers so much easier to have standardized defaults. So it definitely means a lot. Every project that integrates and uses 4626 is really bringing this space forward.
Indeed. I hope the information shared today is really helpful for new projects looking for implementing a standard API for tokenized vault, representing shares of a single underlying ERC20 token. Thank you so very much, Jed, for taking out time and sharing all these information with us. On this note, thanks to all our YouTube viewers for watching and sharing your feedback with comments. Check out description for related links and guest Twitter to follow. If this helped you help others, hit like and share to increase reach. Should you have any question on this proposal or any other talk, let us know in the comment or reach us on ETH Cat Herders Discord. Subscribe to the Ethereum Cat Herders YouTube channel if you haven't done it already. See you next time with another interesting proposal. Till then, keep watching, keep sharing your love with Ethereum Cat Herders. Have a good rest of your day.